In this tutorial video, we will be learning on quantum logic gate and rotation. We will be doing the coding on Google Colab. Like we did in the previous video, we will be starting with the installation of BlueCat. Type the code, !pip install BlueCat in order to install BlueCat. Let us do it in Google Colab. Type the code that was shown earlier. And click on the play button to run the code. BlueCat will be installed after a while. Quantum computations mainly manipulate the state of a qubit using rotation. In this tutorial video, we will be mainly learning on construction about qubit and rotation of qubit. Qubits are the core component in quantum computing. The concept of superposition is important, because this is what qubits or quantum bits is about. When we say the spin of a particle is in a superposition of states, it simply means it is in a linear combination of up spin and down spin. Here is the equation in the Dirac notation. The up spin and down spin are the two orthogonal basis vectors that are encoded as. And it also has a dual form written as. This is the initial state. Here are some more superposition states and the corresponding matrix. This data is called a quantum state and is mainly represented by a vertical vector and can be defined by using up spin and down spin states, which is called a state vector. And the psi state vector can be also represented using this equation. Where the state of the qubits can be represented by two parameters, they are theta and phi. Where theta is the angle between 0 and pi, and phi is the angle between 0 and 2 pi. One qubit can be represented as a point on a sphere. A quantum computer is not constrained by 0 and 1 and can take any point on a sphere called a Bloch sphere. We can visualize the superposition as a point lying on the surface of a unit sphere. The up and down spin is just the north and south pole of the sphere respectively. So the red dot below is another example of a superposition state. When it is measured, nature forces it to take a side, either up or down, to really have the superposition represented as the Bloch sphere above. The amplitude alpha can also be a complex number like. Here are the values of the superpositions in the 6 corners. To calculate the probability, we compute the square of the normalization, that is, multiply the amplitude with its complex conjugate. The complex conjugate of 3 plus 4i is 3 minus 4i. In order to change the quantum state, rotate operation is used. It is called a quantum gate. The Bloch sphere has 3 axes. XYZ quantum gates is such rotational operations around an axis. The basic rotation operation is the X, Y, and Z gates. Each corresponds to a rotation of 180 degrees around the X, Y, and Z axes. The quantum gate can be computed by multiplying the state vector. There are also gates that use more than 2 qubits. Let's have a quick recap on bits versus qubits. A bit represents one of the two possible values, 0 or 1. A qubit represents points on the surface of the unit sphere. For round 1, a qubit wins over a bit on how many states that it can represent. 2 to the power of 64 is about winning the biggest lottery 30 billion times. With 64 qubits, we can encode and manipulate a lot of data using these billion coefficients dimensions. Qubits win round 2. Increasing the qubits linearly, we expand the information capacity exponentially. Thank you for watching this video.